It's December, the month that YouTubers gather around their editing machines and make videos about DOS. It's also the 40th anniversary of the BBC Micro being released. Which video should I do? Yes, I don't have time to make 2 videos this month, but what if I could combine the 2 of them? Could I turn the BBC Micro into a PC and get DOS running on it? Well, yes, otherwise this wouldn't be a thing. For those of you not familiar with the BBC Micro, it was a machine created by Acorn Computers Limited, that here in the UK dominated the educational market. It was the machine the BBC selected to go with their educational programme, and it had to meet a pretty tough criteria. It also had one very unique feature, one that no other 8-bit micro of the time had. Yep, I'm talking about the tube port. The tube let you add a second processor to the BBC Micro, and in this configuration you'd have the 6502 CPU that's in the BBC Micro handling I/O, disk, screen, that sort of thing, while the application code, yeah, that would run on your second processor. Now, that second processor did not have to be a 6502, although admittedly that probably was the most popular second processor for the BBC, as it let you have a much faster 6502 running at 4 MHz rather than 2, because it didn't have to share access to memory with graphics and stuff like that. It also had 64K of its own RAM. No, there were lots of different CPUs available for it, like the Z80. Also, the first ever ARM microprocessor. That was done as a second CPU for the BBC. That's how they did all the testing for it, and made it available as an evaluation unit, so people who were writing software for ARM, well, they had something that they could run their code on. Now, the second processor we're going to look at today, yeah, is the 186. The 186 was initially intended as an x86 compatible embedded processor, and didn't see widespread use inside PCs. However, UK viewers may be far more familiar with the 186 than everybody else, as it did get used in a number of PCs here. For example, RM's line of Nimbus computers used the 186 processor, as did a number of other budget-conscious PCs here. For Acorn, the 186 hit a nice sweet spot between performance and price, which is why when they were looking for an x86 processor, that's the one they went for. The second processor was initially released as part of the BBC Master 512. The Master was an updated version of the BBC Micro and had an internal tube port, so the board was fitted in there, which saved Acorn having to produce a separate external casing for it. However, it was still entirely compatible with the BBC Micro and was sold as a separate add-on. So you could purchase an external coprocessor housing, pop this board in, and away you'd go. Watford Electronics probably made the most popular of these external housings. So, armed with a BBC Micro on this board, you had yourself an IBM compatible-ish PC. Now you may be wondering to yourself, why would anyone want an IBM compatible-ish PC? Well, Acorn were far from being the only people making one of these things. Many of the PCs available at the time were IBM compatible-ish. For example, RM's line of Nimbus machines we mentioned earlier were IBM compatible-ish. In fact, to be honest, the Master 512 was probably more IBM compatible-ish than it was, and it was only a PC. Apricot also had a line of IBM compatible-ish machines, as did a whole bunch of other vendors. Later on, compatibility with IBM's BIOS would get a lot better, particularly after manufacturers like Compaq had entered the scene with their very IBM compatible BIOS. In fact, their BIOS was a bit more compatible with the original IBM machine than later IBM machines were. But at this point in time, compatible-ish was good enough-ish. In fact, we'll have a little look at compatibility later on when we get further into our video and get our hands on the machine itself. Now, the Master 512 and the board came bundled with its very own special version of DOS. See, we get to the doscember bit of this eventually. Yet, the version of DOS it shipped with was DOS Plus. Initially version 1.2 and later on version 2. Now, for those of you sat at home thinking, I don't remember MS-DOS Plus, what's that? Well, it wasn't Microsoft DOS Plus, oh no. DOS Plus was made by Digital Research, the people who created CP/M. Now, plenty of you will be familiar with the significance of CP/M. CP/M was an operating system that predated DOS and was in fact the operating system that IBM initially wanted to bundle with its PC, because it was the de facto business operating system of the time for small micros. But as negotiations didn't quite work out as IBM had planned, they asked Microsoft if they could produce something CP/M-like. Microsoft then went out and purchased the rights to a bit of software that was like a CP/M operating system. In fact, it was very like a CP/M operating system. In fact, it turned out, later on discovered through court filings, it literally contained parts of CP/M. Yes, this did lead to many legal battles. So as DOS overtook CP/M with the rise in the popularity of the PC, you can imagine Digital Research were quite keen to get a slice back of their own, well, what they saw as their own operating system's market share. So they produced an updated version of CPM, a version of CPM for the x86 processor that, well, could run DOS software. And they called this thing DOS Plus. At its core, it's still the same CPM operating system they'd been offering before, just with an additional DOS compatibility layer plopped on top. This would provide compatibility with DOS 2. Now, there were a number of reasons for Acorn to go this way. Firstly, Digital Research were a lot more willing to work with people. I mean, they wanted to claw back market share, so they were pretty open. The other advantage is, this version of DOS meant you could run any CPM software for the x86 version of CPM. So there was a pretty big back catalogue of applications that were just compatible and ready to go. Then with the DOS 2 compatibility layer, well, that meant you could run a lot of MS-DOS applications as well. Although not all, that's where the whole IBM compatible-ish thing comes in. But again, we'll get to that more later on in the video. Acorn were not the only people shipping DOS Plus with their machine as well. Amstrad had it as an option for all of their IBM compatible-ish mostly PCs. Which at the time, if you wanted to buy an IBM mostly compatible PC in the UK, yeah, Amstrad were one of the biggest vendors because, well, they had a price point that people could actually roughly afford. Acorn was very upfront about what was and wasn't IBM compatible with this thing, going so far as to produce a nice document with all the technical differences between the two systems. Most of them lie around calls that set things specifically about hardware, like do stuff with the serial port, for example, that the underlying BBC hardware, yeah, it couldn't do. One of the more niggling bits was about how keyboard interrupts would work. A number of bits of software, mostly games, handled keyboard interrupts directly into their loop, rather than using the DOS functions for getting the keyboard data. This caused a problem for the BBC because an interrupt wasn't generated by the BBC's keyboard on the x86 side of things, as the BBC's keyboard worked very differently. Yeah, an interrupt would be generated to the 6502 in the BBC that would then send it across the tube interface to the coprocessor. I mean, that was fine for DOS. DOS could then pick that up, use its normal output method to applications, and there you go, keyboard handling done. Except for when an application bypassed it and went straight to the keyboard interrupt itself. Yeah, it just wouldn't get the keyboard interrupt. Now, later on, a handy little utility called PCCE came along that was there to extend essentially the compatibility of DOS Plus for the BBC Master. And, well, that actually introduced the keyboard interrupt again. Essentially, it faked it through software. It read it via the normal channel, generated the interrupt itself, sent it out to the game. So that way, some games that relied on this, yeah, they could actually work. You might have assumed this would create a few latency issues, but based on me playing on this thing, no, not really. I can't really notice any lagging keyboard input. Everything seems to be fine. The only reason not to have this utility loaded all the time is it takes a little bit of memory, and well, 512k, while a lot for a BBC, was about roughly where the minimum was for a PC at this point in time, so having things take up extra RAM, yeah, not ideal. Also, DOS Plus itself used a bit more RAM than MS-DOS, about 20k more, which again, does not sound like a lot, but when you've only got 512k, yeah, it's a reasonable chunk of memory. Keyboard was not the only area of input device compatibility problems as well. Initially, there was no mouse support for any DOS-based stuff. I mean, there were mice available for the BBC, you could plug them in, but they did not work with any of the DOS stuff. Luckily, eventually someone produced an MS-DOS mouse driver for this thing, so finally, any DOS-based mouse stuff actually worked, which is pretty handy for games that relied on the mouse or editing software. Now, this lack of compatibility with the mouse and DOS seems particularly weird when you find out that the Master 512, yeah, it came with a mouse. Now, the reason it came on with this mouse, well, we'll get onto that in the big reveal in a second when we actually wheel the machine itself out. In fact, let's not delay, let's get the machine out. Here is the machine I'm going to be using as my Master 512. Now, this is a regular Master 128. It didn't come pre-built as a Master 512. No, I've upgraded it after the fact. Now, I haven't bought myself an original Master 512 board because, man, they're pretty expensive actually. Luckily, some clever person came up with an idea called the Pi Tube, which lets you use a Pi Zero to be any of the BBC's co-processors. There's even an internal version of that board that's fitted inside this very BBC Master. And the other handy thing about this BBC Master is, yeah, it's got a hard drive in it. I mean, it's a compact flash-based one, but it's got a hard drive. Now, most people probably never realised that the BBC could have a hard drive because, well, they cost considerably more than the BBC itself. So, they were super rare. I mean, I've got one here you can have a look at, and it's a chunky beast. I mean, there's a power supply in there, the giant hard drive, and also a SCSI to 1 MHz bus adapter in there as well. So yeah, there's a lot of hardware crammed into this overly heavy tin box, including a couple of house bricks, I assume. I'm not just bringing this up for no reason. One of the things DOS Plus could do if you had a hard drive, yeah, DOS Plus could use it. Yeah, there's a handy utility on the install disk called HDisk. This creates a hard disk file there on the hard drive. On the regular ADFS partition that your BBC uses, you end up with a file in there that becomes the hard drive for your DOS Plus environment. You know, it's pretty sweet. Now, everything I'm going to show you here could be done with the original BBC Micro. You could hook that massive hard drive up to it, you could stick the coprocessor in an external box, and away you go. The only difference would be you don't have the numeric keypad, which, you know, for a limited number of bits of software, may be a bit of a pain in the arse, particularly flight sims. Right, time to watch this thing boot up. As you can see, it starts off with the regular BBC's operating system, the one that's built into the ROM. That searches all of the available disks for the file DOSBoot. It then runs that code on the BBC side of things. We then swap to this splash screen here. What that bit of code's doing is turning up the 186 processor and pushing the boot code that needs into memory. What that bit of boot code contains is a couple of little things. First of all, it pops in the stuff that puts in this splash screen. It also pushes in their Acorn's equivalent of the BIOS, XIOS. Now this does the job of the BIOS in a normal IBM PC, but it's got a couple of little extra things in there as it's all geared around talking across the tube interface back to the host machine, including a very clever way of doing CGA, which we'll come on to later when we look at some of the games. Once that boot code's in, you get a little bit of a prompt if you've got a hard drive asking if you'd like to boot from it, or you can boot from a floppy disk. The choice is yours. In terms of boot media, it doesn't matter whether this is an ADFS hard drive or an ADFS floppy. Either way, it's pretty content to get booting. The hard drive is a lot faster though. The rest of DOS Plus is then read from the disk, just like MS-DOS would be after the BIOS has kicked in a PC. And there you'll find we're sitting a very familiar looking command prompt. This has all the normal options that DOS has. We can even have an auto-exit.bat to put custom stuff in every time we boot. Given we've got a hard drive fitted to this BBC, we're going to install DOS Plus directly to it. Now on the disk there is a very simple to use partitioning utility that creates the hard disk file for you, and then after that you call a simple install script. I mean, it really is something you just type in the name of it and go basically, and it goes through each of the floppy disks in turn. I'll speed this process up massively because otherwise we'd have 20 minutes of you just slowly watching files copy off a floppy. Right, with DOS Plus installed, all we need to do is just press Control Break on the machine and it reboots and gives us a prompt to boot from the hard drive. And there we go, we're now booted from a BBC running DOS Plus using the hard drive. Pretty cool, huh? Now earlier I mentioned that this thing came with a mouse. In fact, I'll show you a picture of the mouse now. I mean, it's not an attractive mouse, but a mouse it is. I also told you that that mouse does not work in the DOS side of things either. So if you have a DOS application or game that uses the mouse, yeah, as it came it wouldn't work. Until someone eventually created a mouse driver utility for us. So I'm now going to answer that burning question. Why on earth did it come with a mouse if the mouse doesn't work in DOS? Well, as I mentioned before, DOS Plus is CP/M with a DOS compatibility layer. And at this point in time, Digital Research wrote something that was pretty special for its CP/M operating system. Yep, the GEM desktop. Now Atari ST users will be very familiar with this. Yep, this is the same GUI that the Atari ST ran, as Digital Research did all the work on Atari's operating system. Now, GEM was not just available for CP/M, it was also available for MS-DOS, and, well, Digital Research did try to sell it to PC owners. In fact, initially, they did fairly well. I mean, it had a clear advantage. It came out at the very beginning of 1985, whereas Windows 1 came out at the end of 1985. And people didn't like Windows 1. Windows 1 was slow. It's kind of a bit rubbish, really, and, well, to be honest, GEM was faster. I mean, as you can see, it runs at a reasonable speed here on, not quite a PC. It wasn't until Windows 2 and then later Windows 3 that Microsoft really started to dominate this whole GUI market. And GEM went by the by, as did IBM's TopView. So in 1986, when our Master 512 came out, yeah, having a GUI was still pretty special. Most PC users, yeah, didn't have a GUI. Now, we only get two sample applications with this, Write and Paint. Paint is a black and white type painting program because that's, well, displaying everything in the black and white mode here. And Write is, well, a word processor. I mean, a fairly simple word processor, but at the time, again, quite nice with its whole what you see is what you get approach. There were more than just the 2 gem applications we see here. There are a whole number of applications developed for it. And from a compatibility point of view for the Beeb, yeah, this was great. If it worked in gem on any other x86 box, it worked on this one. Although gem was released for an awful lot of CPUs, so unsurprisingly the Atari gem applications, yeah, don't work on the BBC because it's a different CPU architecture. Now we've seen gem, let's get back to the DOS side of things. After all, it is doscember. Now, fortunately for us, Acorn did produce a list of software that the Master 512 worked with. Which, saves me a lot of trial and error, and I can now tell you in the video that, yeah, it did actually support most of the major applications of the day. Lotus 123, WordPerfect, even Sage Accounting. Which, if you're in the UK and you had a small to medium enterprise, yeah, that's actually quite a big one. Yeah, Sage is in fact still in use today. So, with all these major applications supported, yeah, were much in the way of games supported? Well, this gets a bit more interesting. Remember I said I'd talk more about compatibility? Well, here comes the bit about graphics. Now the earliest graphics adapter for the PC was CGA, Color Graphics Adapter. And that's what our Master 512 supports as well. Now you may be wondering, how does it do that, given that the BBC's graphics chip is very much attached to the 6502 processor and not in anywhere near on the Master 512 board? Well, this is where Acorn had to be a little bit clever. You see, although the BIOS and DOS had calls to do graphics, they were slow, I mean really slow, to the point where almost no games or any software that directly did graphics made use of those calls. Most software that did graphics in CGA just went to the memory addresses on the CGA card. Now, as this add-on board doesn't have its own graphics card, it had to be a little bit more clever. What would happen in the background is a timed interrupt would run, and it'd keep checking the bit of memory that was mapped to where the CGA graphics adapter was. If any of the data in that memory range had changed, well, it'd push the differences across the tube interface to the 6502. It would then make corresponding changes in the graphics RAM in the BBC itself to get the changes reflected on screen. This approach meant that CGA graphics compatibility is actually pretty good, to the point where we can get some games running. It did have a downside, however. Normally in the PC, a CGA card will have its own memory, and in the 512, well that's not true, so the memory used for graphics, it had to come out the 512K that's built into the card. Right, so let's have a look at a number of games. Now first I'm going to start with one that didn't work. Yeah, you might find this quite surprising, but it's interesting as to why it doesn't work. Now the game I've got here is Outrun for DOS. Yep, the DOS port of the classic arcade game. I chose this for 2 reasons. One, I really quite like Outlook and I thought it might show off what this can do. And second of all, I know someone who also really likes Outrun, so I thought this would be a bit of a treat for him. But sadly it was not to be. As you can see, the actual CGA graphics part of it works fine. We get the title screen, that loads up. We then press a key to move on to where you'd select the tune you're going to drive to. And this is where things go wrong, because, yeah, we don't actually have a sound card in this machine. Yeah, no AdBlue card, no nothing. And so the screen seems to go wrong here whenever it tries to play some music or sound. In fact, it was not the only game to go wrong when it got to the bit where it plays some music. There are a few games that had a title screen that worked, loaded the beginning of the game, and then it took you through the menu and you knew it was going to start playing music, and then, yeah, that's when the game died. The games where no sound's an option, well, they seem to work a lot better. Now, earlier DOS games where the graphics are a bit more simple than Outrun, and it wants a PC speaker at best, well, virtually all of them I tried seemed to work. I mean, here's me playing a couple of them here. Odd, nice selection. Now, these range from your text adventure with a bit of graphics, or completely just text adventure, to fairly simple arcade type stuff, the sort of stuff the BBC would have no problems doing itself. So I decided to try something that was a bit more intensive on the CPU. I tried this helicopter simulator here, where it's doing, fairly complicated 3D graphics, or at least for this point in time, and yeah, that runs pretty smoothly. It's surprisingly alright. I also decided I'd try Planet X3, because everyone seems to use this to show off retro PCs these days. Actually, it is quite a good game. Cheers, David. And look, it works just fine. The colours I think are a little bit different than some of my other CGA boxes, but that's sort of to be expected. But yeah, this is totally playable, and pretty smooth. No lag. Right, now we'll have a look at some of the special stuff we can do in here that you can't do on a regular PC with DOS+. Let's start with its handy utility, Star. Now, those of you not familiar with the BBC probably don't know, but the BBC's operating system used a series of star commands to tell the difference between the language interpreter that was currently loaded, usually BASIC by default, and instructions intended for the operating system. So you do things like star dot to list files, star roms to list the number of roms in the machines, that sort of thing. Now, the utility spelt star rather than just the star character, well, that was provided so we can still issue commands to the BBC's operating system, but from the DOS Plus environment. So I can type in star space dot, and there we go, that's the equivalent of star dot. It lists out the current selected BBC filing system and directory. We can do the same with the ROMs. Here we go, star space ROMs. There you go, lists all the ROMs installed in the BBC. This is really handy because you can attach to different filing systems on the BBC side, including even Econet. We can actually log into a file server with this and start transferring files in and out, which brings me to the next two utilities. Yep, DOS Plus came with a utility to transfer things into the BBC filing system or out of the BBC filing system. It is get file and put file. This means, combined with the star utility, we can log onto a network, we can copy our documents on and off a network file server, which is something, to be honest, most PCs at the time really didn't have the option to do because DOS networking, really wasn't big at this point. Econet was far more widely deployed than any other LAN technology, or at least in the UK at this point in time. Other cool things is we have a version of BBC Basic for DOS Plus. Yep, from Richard Russell, creator of the Z80 version of BBC Basic, also created for us a DOS version. Now you may be wondering, given that BBC Basic was built into the machine, why on earth would you want to use BBC Basic when you're in PC mode? Well, the name's in the title of the board, 512. Yep, we had 512k to play with. That is a heck of a lot more than the BBC B's 32k or the Master's 128k. You could write much bigger BBC Basic programs in this thing. Now, given that there are a number of basics available for DOS, including QBasic and Microsoft Basic, you may be wondering, why use BBC Basic? Well, there's a reason. It's better. I'm not just, it's the one I preferred and grew up with, therefore I'm calling it better. I mean, it had a lot more functionality than those other basics. For a start, we had procedures and functions. That was a pretty big step up. And a really nice built-in assembler that let us define assembly functions right there in the basic listing and put them inside procedures so we could call them from our basic code. Now, this is much nicer than the arrangements of other basic, where if you wanted some machine code, essentially you had a data statement that just put machine code directly into RAM and then you'd somehow force the execution pointer to this. No, here you got the full assembly listing and everything. And in the PC version of it, well, we got PC Assembler. Yeah, you can do Intel Assembler right there in the thing. Let me show you this program. As you can see in here, yeah, we got a nice example of x86 assembly instructions in there. Just in line, just like you would with the 6502 instructions in regular BBC Basic. It's actually really nice. We can even do graphics and stuff as well, because, yeah, graphics are an actual thing in BBC Basic. As an FYI, Richard Russell continued developing BBC Basic and it's still available today. For Windows, Mac, Linux, you can even do a sort of web target as well. Yeah, there's even OpenGL support in it now, so you can do full 3D in there. Although we had all this BBC stuff on the DOS end of things, you could flip things over the other way, and this card actually provided some utility to the regular BBC OS as well. So you can actually use the thing as a RAM disk, so you'd have a fairly massive half meg RAM disk in there, which was really good for being able to copy the contents of floppies around, etc. If you made it this far, I'd like to say thank you very much for watching, and just to say in summary, I hope you've enjoyed this look at a particularly different PC and a very interesting version of DOS. If you enjoyed this video, why not like and share it with friends? As who knows, they might like a video about DOS Plus and a semi-PC compatible PC. And of course, as ever, if you haven't subscribed to the channel, please do. It makes a huge difference on how much the algorithm, tells people that we exist.